Okay, so let's talk about a couple more properties of exponents. So this is still Module 5. And we're now talking about Section 5.2. We'll continue on with properties of exponents. So more properties of exponents. Okay, so you remember when we talked about multiplication properties last time, we had b raised to some power m, and we had the same base, b raised to some power of n. We had b to the m plus n. We simply added the two exponents, right? As an example, if I had a to the 5th times a to the 6th, that simply equals a to the 5 plus 6, and that's a to the 11th. Right. And we talked about division. So we had, if I had some base b to the m divided by b to the n, I subtracted them. So I had b to the m minus n. Again, it was the exponent in the numerator minus the exponent in the denominator. And as an example here, I would have, say, x to the 9th divided by x to the 6th. And I would have x to the 9 minus 6, or x cubed, right, or x to the 3rd. Okay, so let's talk about a couple more properties. So those were division and multiplication. Now we talk about the power rule. So this is now written slightly differently. So if I have some base that's raised to the m, and it's in parentheses, and I raise it again to the nth power, I'm no longer adding them, right? So I have, this becomes b to the m times n. Here I am multiplying my exponents, right? So for example, if I had x squared, and I raise that to the 3rd, I get x to the 2 times 3, or x to the 6th. Right, because what we're really saying is, remember, anytime we're raising it, it's x squared. We're doing it 3 times what's inside the parentheses. Whoops, that should have been a 2. And then I would be adding all of my exponents here, and I get x to the 6th. Let's try another example. Say y to the 3rd, all raised to the 5th. That's just y to the 3 times 5, which equals y to the 15th. Okay, notice the difference. Notice the difference. Between y to the 3rd times y to the 5th, right, and y to the 3rd raised to the 5th. In this case, right, I have y to the 3 plus 5, which gives me y to the 8th. Whereas here I have y to the 3 times 5, which gives me y to the 15th, okay? So notice the difference in our notation here and what the different rules are. Okay, so now if we continue, let's try something a little bit more complex, and we'll have a couple of variables inside that's all raised to a certain power. So let's say I have q to the 5th times q to the 4th, all raised to the 3rd. Well, for me to simplify that, actually if I look in here, I have like bases, right? So that becomes q to the 5 plus 4 inside, right? right, all raised to the third. So that's q to the ninth, all raised to the third. And I get q to the 27th. Okay. I can also have a couple variables, like I was saying, inside the parentheses. So let's say I'm going to talk about the property of, I have two variables, a and b. If I have two things inside parentheses and they're all raised to some exponent, I'm going to make it a to the m times b to the m. So each one of them gets that exponent. Okay, and similarly, if I have a over b, and all of that's raised to the m power, I get a to the m all over b to the m, as long as b doesn't equal 0, right? Because if b equals 0, then that doesn't, 0 under the line is undefined, right? So let's try an example here. Example, simplify xy all raised to the fourth. Right, that's simply x to the fourth, y to the fourth. And similarly, if I had y over z to the fifth, that's just going to be y to the fifth over z to the fifth. I should make my exponent a little bit more obvious there, so I'll do z to the fifth, right? Okay, so let's review a couple things that we have. I will do this. How about simplify five u cubed w squared. Okay, so now notice again we have a bunch of multiplication inside here. But what I want you to notice is this 5 is also itself a base, and it has an exponent of 1. Okay. I'm sorry, this should have been raised to the third. Okay, so now what I'm going to do is I'm going to take each one of these and I'm going to multiply it out. So it's like saying I have 5 to the 1 times 3, u to the 3 times 3, and then w to the 2 times 3. Right, so this 3 gets multiplied with each exponent. This 3 goes to multiplied with that 1, this 3 multiplied with the 3, that 3 has to multiply with that 2. So then I get 5 cubed, u to the 9th, w to the 6th, and 5 cubed is 5 times 5 times 5, which gives me 125, u to the 9th, w to the 6th. Okay, let's do a couple more examples. What if we had simplify w squared all over 6v to the 4th. And all of that is squared. Okay, so now again I'm going to break that apart, right? This is like saying I have w squared, that was what's on top, still squared, and then on the bottom I have 6v to the 4th, and that whole thing is squared. Right? So now if I use my power rules, I have w to the 2 times 2. Right? And then remember again, my coefficient is also its own base. It has an exponent of 1. so that would be 6 to the 1 times 2, v to the 4 times 2. Right? And now if I simplify that, I get w to the 4th all over 6 squared, v to the 8th. And if I keep going, 6 squared is 36, so my final answer is w to the 4th, 36, v to the 8th. Make that w look a little bit better. Okay. Let's do a couple more. So now what if I ask you to simplify negative 3 x y cubed z to the 4th times 2x squared y cubed z. And all of that is raised to the 3rd. Okay, so somehow I lost my x over here. All right, so I would look at this part first. Okay, so I'm going to go ahead and keep this out here. I have negative 3xy cubed z to the 4th. And the reason I look at the second part of it is because I don't see an exponent up here, right? There's nothing there. So I don't have to actually do anything to the contents inside those parentheses. I do, however, have to, since this is using the power rule, I do have to take this 3 and I'm going to have to multiply it with every exponent inside, right? And so again, remember, I have to look to see if I have a base and I don't have an exponent, that coefficient has an exponent of 1. This z also has an exponent of 1. Okay, so let's go and start multiplying each one of these out, right? Okay, so I'm going to have 2 to the 1 times 3, right? X to the 2 times 3, y to the 3 times 3, and I still have z to the 1 times 3. Again, I'm writing it all out. I know it's a little bit cumbersome, but we'll simplify this out quickly. So I still have negative 3xy cubed z to the 4th. And I think it's good to write down things even if you haven't changed it, so you're not just changing the problem in between. So now I have 2 to the 3rd, x to the 6th, y to the 9th, z cubed. Okay, so now I have a bunch of multiplication, right? And we can go back and use our multiplication rules. I'm going to group like bases, right? So here I have a 3, and then 2 to the 3rd is 8, but I'll go ahead and move those closer together, times 2 to the 3rd. Okay? And then I'll look at my x's. So here I have an x to the 1 and an x to the 6th. So I'm going to write x to the, that's known to be 1, right, times x to the 6th. And then I have a y to the 3rd, y to the 9th. So I have y to the 3rd, y to the 9th. And then lastly, I have my z's, right, z to the 4th, z to the 3rd. So z to the 4th, z to the 3rd. And again, I know I'm writing a lot out, and eventually you'll see this very quickly, so you don't have to write all that. But here I'm going to take negative 3 times 8, and this is going to be x to the 1 plus 6, or x to the 7th. This is y to the 3 plus 9, or y to the 12th. And then this is going to be z to the 4 plus 3, or z to the 7th. So my final answer will simply be negative 24, because that's what 3 times 8 is, right? Negative 3 times 8, x to the 7th, y to the 12th, z to the 7th. And that's simplified.